Hey, Jason here from Simply Swider. So if your Whirlpool microwave is powering on, the display's working, the turntable's spinning, and everything looks normal, but the dang thing just won't heat your food, don't panic. I'm going to show you exactly how to fix it. Good news is
Ugh,
most of
it's
these issues are
completely
totally
soggy. I can't eat
DIY-able if
this.
you're comfortable with basic
Mm.
electrical work. Though I got to warn you up front, we're dealing with some high voltage components that can be dangerous. Before we get started, if you run into any questions, jump into our Facebook group. Links in the description. We've got thousands of people helping each other fix their appliances, and I pop in there daily to help out. Here's what's really happening when your microwave runs but won't heat. All the low voltage systems are working fine. That's why you see lights, hear the fan, and watch the turntable spin. But the high voltage circuit that powers the magnetron is failing. The magnetron is what actually creates the microwaves that heat your food. Think of it like a car where the radio and lights work, but the engine won't start. Different systems, different problems. Real world breakdown here. Magnetron failures are the big one, probably 85% of these cases. Door interlock switches are next, then high voltage diodes, capacitors, and transformers bring up the rear. We're going to diagnose in that order because it saves you time and money. All right, so the magnetron, this is your microwave's heart. It's that chunky vacuum tube that converts high voltage into actual microwave radiation. Now, I got to tell you, this is probably what's wrong with your unit. These things fail from normal wear and tear, and here's something most people don't know. Running your microwave empty will kill a magnetron fast. The microwaves bounce back into it with nowhere to go. Here's a critical tip: never run your microwave empty. It will kill the magnetron in just a few weeks. The microwaves bounce back with nowhere to go and destroy the internal components. To identify magnetron failure, listen for these warning signs: loud buzzing or humming during operation or rattling sound when you gently shake the removed magnetron. That's broken magnets inside. Testing it is straightforward. Unplug everything, remove the magnetron, and test continuity between the terminals. Should read less than 1 ohm. Then test from each terminal to the metal casing. That should read infinite resistance. If you get any reading there, it's shorted to ground and done for. Here's where people mess up though. Even if it tests good on the meter, those internal magnets can be cracked, and you won't know without hearing that rattle. These little guys are safety switches, usually 3 or 4 of them, that prevent the microwave from nuking you when the doors open. They take a beating from people slamming the door, and after thousands of cycles, they fail. I remember this lady who called me panicked because her microwave would only heat if she pushed up on the door while it was running. Classic door switch problem. What happens is the internal springs break or the contacts get corroded from electrical arcing. Sometimes it's not even the switch. The plastic bracket that holds the switch can crack or get misaligned, so the door hook doesn't hit the switch properly. Testing these is easy and safe since we're dealing with low voltage. Unplug the unit, remove the control panel, and test each switch with your multimeter for continuity while you press the little actuator button. Normal switches should open and close cleanly. The tricky part is knowing which switches are normally open and which are normally closed. Your wiring diagram will tell you that. Don't just start replacing switches randomly. The high voltage diode works with the capacitor to double the voltage going to the magnetron. These fail from power spikes or just plain old age, and here's where a lot of DIYers get tricked. If you test this diode with a regular multimeter continuity test, it's going to show open in both directions because of its high forward voltage drop. People think their meter's broken or the diode is bad when actually it's fine. The right way to test it is with a 9-volt battery in series. The diode should only let voltage pass in one direction. I've seen folks replace perfectly good diodes because they didn't know how to test them properly. When these fail, you'll get the same symptom: runs but no heat, sometimes with buzzing noises. If your main fuse keeps blowing, a shorted diode could be the culprit. Here's a pro tip: anytime you replace a magnetron, replace the diode too. They're cheap insurance and often fail together. Danger alert: this capacitor stores over 2000 volts and can kill you even days after unplugging the microwave. If you're not trained in high voltage safety procedures and don't have proper insulated discharge tools, stop here and call a professional. This is not worth risking your life. The capacitor works with the diode to boost voltage to the magnetron. When it fails, it usually goes one of 2 ways. Either it shorts out and blows your main fuse instantly, or it fails open and won't hold a charge. Visual inspection will often tell the story. Look for a swollen or puffy case or oily residue leaking out. For testing, you need a capacitance meter to check if it matches the microfarad rating on the label. With a regular ohmmeter, it should show brief resistance then climb to infinity as it charges. Here's where people get into trouble. They keep replacing blown fuses without realizing a shorted capacitor is the root cause. That new fuse is going to blow immediately too. The transformer is least likely to fail, but when it does, you'll know it. We're talking thick smoke, burning smells, visible arcing, the whole 9 yards. This beast takes your 120V household current and steps it up to about 2000 V for the high voltage circuit. Here's something specific to Whirlpool. Some of their models use aluminum wire in the primary windings instead of copper, and those factory solder joints fail over time. The varnish coating can make your meter think there's no continuity when actually it's just not making contact through the insulation. Testing is straightforward. Primary winding should read less than 5 ohms, secondary should be between 35 and 150 ohms. But here's the critical thing. Never try to repair broken solder joints on a transformer yourself. I don't care how handy you are, this is a fire hazard. The whole transformer needs to be replaced. These things are heavy as heck too, so be ready for some wrestling. The Magnetron is your biggest expense. You're looking at $100 to $250 for the part alone. Cannot be repaired, only replaced, and it needs to be an exact OEM match. Installation difficulty is moderate if you're comfortable with high voltage safety, but this isn't a beginner repair. The capacitor discharge procedure is critical here. I had a customer try to DIY this last year without proper safety gear. Ended up in the ER with electrical burns. Don't be a hero if you're not trained. Way more common than you'd think. These failures make up the vast majority of no heat complaints I see. These are the bargain repair, $5 to $40 per switch, and they're totally DIY friendly since you're working with low voltage. The tricky part is identifying which specific switch failed and making sure the mounting bracket isn't cracked. I've seen people replace all the switches when just one was bad because they didn't test properly. Sometimes the switches are fine, but the door alignment is off, so the hooks don't activate them. Easy money saver if you take the time to diagnose correctly. The diode runs $10 to $50, making it one of the cheaper fixes. Problem is, it's often misdiagnosed because people don't know how to test it properly. I replace these anytime I do a magnetron because they frequently fail together. Cheap insurance for about 20 bucks. Testing requires that 9-volt battery trick I mentioned. Don't just throw parts at the problem. Capacitors run $20 to $100 depending on the microfarad rating. This is the most dangerous component in your microwave, lethal voltage that can kill you even when unplugged. If you see a swollen case or oil leaking, it's definitely bad. If your main fuse blows instantly when you hit start, suspect the capacitor. Proper discharge technique is absolutely critical here. Before we dive into repairs, let's talk about whether it's worth fixing. Professional repairs can cost $300 to $400, especially for magnetron replacement. Here's my simple decision rule. If repair costs are more than half the price of a new microwave and your unit is over 5 years old, just replace it. For countertop units under $300, replacement almost always makes more sense than professional repair. Countertop units under $300 are almost never worth professional repair. Over the range units that cost $500 to $800 new, those are worth fixing if they're under 5 years old. Now, before we wrap up, you can see right there on the screen some specific Whirlpool models that have known issues. The WMH 53520 and WMH 73521 series actually had a recall for fire hazard due to internal arcing. If you've got one of those over-the-range units, check if you qualify for free factory replacement. Models using part number W10836753 have that aluminum winding transformer problem I mentioned. And I've seen multiple WMH 31017 AS units with magnetron failures caused by users leaving magnetic splatter covers on the ceiling during operation. Here's your step-by-step diagnostic plan. First, test the door interlock switches. They're safe and cheap to check. Second, inspect the high voltage capacitor for swelling or leaks. Third, test the magnetron if you're comfortable with high voltage safety. Remember, always discharge the capacitor first, and if you're not trained in high voltage work, call a professional. Remember, that capacitor can kill you even when unplugged, so don't mess around if you're not trained. Most of these problems are preventable. Don't run it empty, don't slam the door, and keep that waveguide cover clean. Early warning signs include taking longer to heat food, unusual noises, or only heating when you press on the door. Know someone struggling with appliance problems? Share this video and help them save hundreds on repair costs. Check out my channel for more DIY appliance fixes that can solve common problems for just the cost of parts. If this helped you get your microwave heating again, hit that like button and drop a comment below. Let me know which fix worked for you. Really helps other people with the same problem. And if you haven't already, please subscribe to the channel. We'll get this out to more folks who need to save some time and money. Thanks for watching, and I hope you guys have a great day.